On guys, in this video we are going to see how to evaluate a surface integral. In this particular problem we have asked to evaluate the surface integral of this given function, and also the question says S is the part of the plane C is equal to 1 plus 2x plus 3y that lies above this y coordinate, that is going from 0, this is x coordinate, going from 0 to 3, then y coordinate going from 0 to 2. And to find the surface integral we use this equation, that is double integral f of x comma y g of x comma y, and then square root of 1 plus partial derivative of c with respect to x square plus partial derivative of z with respect to y square dA. Okay, now first of all we have to find the partial derivative of z with respect to x. Here we have the c provided, so we are going to take the partial derivative with this one with respect to x first, and if you do that we treat y as a constant, so this one and this 3y is going to become 0, so we are going to have 2 right here. And if you do the partial derivative of z with respect to y, this x of c with respect to x and y. Now we can go ahead and write our double integral. And also before we do that we have to know what is the g of g of x comma y represents. G of x comma y is, when we have this c function provided, we equate that one to g of x comma y, right? So what are we going to do is we are going to copy this function down, but when we copy, we keep the x square y as it is, but when we copy z, instead of z we are going to plug this function. That's what this means. Okay, now let's go ahead and do that. This is going to become x square y, instead of z we are going to plug this function, so this is going to be just 1 plus 2x plus 3y, and then in the square root we are going to have 1 plus partial derivative of z with respect to x. We found out that one already, that is 2, so this is going to be just 2 square, then partial derivative of z with respect to y, that's equal to 3, so this is going to be just 3 square, and instead of dA we are going to copy dy dx. Okay, since we are doing the derivative integration with respect to y first, we have to put the limits of integration of y first. Okay, that's 0 to 2, so that's going to be our first limit, and then 0 to 3 is the y limits, so that's going to be 0 to 3. Now let's simplify this one. Here we have 2 square, 3 square. 3 square is equal to 9, 2 square is equal to 4, so 9 plus 4, that's going to be 13, 13 plus 1, that's going to be 14. Then we are going to have square root of 14, right? So we can move this square root of 14 to the front because this is a constant, so we can move this one to the front, and then we can copy this integral down. This is going to be 0 to 3, integral 0 to 2, and then we are going to multiply this x square y with this one. Here x square y times 1, that's going to be just x square y, and then x square y times 2x, that's going to become 2x cube y, and if we multiply 3y times x square y, that's going to become 3x square y square. Okay, then dy dx, first we are going to integrate this one with respect to y, and if we do that this is going to become x square y square divided by 2. Then if we do that for this one, 2x cube y square divided by 2, since we have the 2 in the numerator and the denominator, these two going to cancel each other, so we just have to copy this x cube y square here. Okay, now if we do the integration for this one with respect to y, this is going to become 3x square y cube divided by 3. Since we have the 3 in the numerator and the denominator, 3 are going to cancel each other, so we are going to be left with x square y cube, right? Now we have done the integration, that's going from 0 to 2, and the next thing is we have to do the integration with respect to x, but before we do that we have to substitute these values. Now let's go ahead and do that. If we substitute 2 for y, it's better to write y is equal to 2. Sometimes you might miss that one with, like, you might miss that one with mix that one with x. Okay, so it's better to write y is equal to 2, y is equal to 0, y is equal to 2, y is equal to 0, and if we plug 2 for y value, this is going to become 2 square divided by 2, that's going to be 4 over 2. 4 over 2 is just 2, so we are going to have 2x square right here, and then here we are going to have x cube y square. Y square is going to become 4x cube, and then y cube, 2 cube is equal to 8x square, and that's it. Now we are going to integrate this one with respect to x. Now let's go ahead and do that, and if we plug 0, everything is going to be 0. We don't have to do that part because you can see this one is going to become 0, this one is going to become 0, this is also going to become 0, so we don't have to do that part. Now let's go ahead and do the integration with respect to x. If you do that, this is going to become 2x cubed divided by 3, and the next one is going to become 4x power 4 divided by 4. 4 cancels each other, so we are going to have x power 4, and this is going to become 8x cubed divided by 3. Okay, 8x cubed divided by 3, that's going from 0 to 3, and then we have to multiply everything by square root of 14. That's our constant. Okay, now let's continue this one right here, and if we plug 3 for this x, 3 cube is equal to 27. 27 divided by 3, that's going to be 9. Then 9 multiplied by 2, that's going to be just 18, right? So this is going to be 18, and outside constant we just keep it as it is, so that's going to be square root of 14. Then x power 4, here we plug 3 power 4 is equal to 81, so this is going to be just 81 plus 8 x cubed divided by 3. 3 cube is 27 divided by 3, that's going to be 9. 9 times 8 is equal to 72, and that's it. Then if we plug 0, all of them are going to become 0, because you can see this one 0, this one 0, this one 0, so we are going to have this one as the final answer. All we have to do is just add them and express the final answer, and if we add them together, that's going to give us 171 and square root of 14. That's going to be the surface integral of this given function. I hope this helps. Thanks for watching.